So hello, this is Glenn, and in today's video we're looking at metamorphic rocks. So this is just an introduction, and we have the 4 grades of metamorphic rock. So we have slate, firelight, schist, and gneiss. And this is a gradation, so the slate has a low pressure and the gneiss has high pressure. But there is also a difference in the way they form, but I won't go over that in this video. Basically, here I have a shale. So this one I got in the field near Bacchus Marsh, and it is a mudstone. So it is slightly pressurized, so it's been through some pressure. Not enough pressure to alter any of the minerals, but as you can see, it has a lot of sedimentation, but this is basically formed because of the way it has been laid down. And here's the mudstone. So mudstone can lead to slate. Then slate, when it goes through some pressure and heat, turns into shale. So here is some shale, and you can see you can't really tell the difference between both of these. So the only difference is probably the slate can break a lot easier than the shale. But as you can see, there are bands on it. So this rock is starting to form in the direction of its pressure. So the pressure would have been top to bottom. So that's where the most pressure is. There on the sides would have had not enough pressure. It would have had some pressure, but it would have been squeezed out so that the mica or the clays are forming in the direction that's been put under pressure. So as the bands are being formed, the mica is lining up in this plane. So that's why you see the lines on there. It looks like straight lines. So anyway, that is basically the difference. And as you can see, the slate is slightly a different color. It's a darker color. So that also depends on the type of precursor mudstone. So slate and firelight come from mudstone. Okay, so they have to come from shale and they have to come from mudstone. But then we have the schist and the gneiss. While they do need to have plate forming minerals in them to produce what they got, they don't necessarily have to come from a mudstone. They could come from a sandstone or even another, like this one. This one might have been granodiorite. I'm just guessing here. I'm not too sure the precursor rock. And this one, look at the color, so gneiss. And that could also be a granodiorite or even a diorite, because of the large number of dark color minerals in it. And as you can see, the pressure of this gneiss is probably not as much as the ones you see on the internet, which are really banded. So this one probably was not fully developed. That's just my guessing. And let's have a look at the firelight and the slate. So the firelight, when you look at it, it should have a shiny reflection to it. And that's because the mica is becoming more pronounced. The crystals are a lot larger than in a slate. So it's been starting to be recrystallized. So even though it hasn't been melted, the crystals are moving. So that's why they form an orientation. So this orientation is that way or that way, doesn't matter which way. You can see it comes off in plates. You can see all the plates on the actual rock. So that's the foliation. So these both are foliation. The schist is foliation, but the gneiss does not, because as you can see, it's pretty massive. It does have lenticular form, so it does have lines going through it, but it does not break off in plates. So here we have the micas that we have just in the pure forms. This is muscovite, biotite, mica, and as you can see, they're all platy. They're all reflective. So these are an aluminium silicate, and when they break down, they just form clays. Also, feldspars form clays as well. They're all different types of clays, but these are very common in the actual rock. And as you can see, we have this rock starting to break apart. So that is the micas, and that's pretty much why these rocks form plates. So we call them plates because, you know, they're pretty flat. And if we zoom out, they are pretty much why they are metamorphic rocks and they have foliation. So the phyllite does form plates because the crystals are a lot bigger than the slate. They have a slightly shiny, but they're not as shiny as what a pure mica is because the impurity. So this probably has quartz. No, it does. It still has quartz. It has feldspars, hornblends, but the hornblende is probably starting to change at this time. That's when we come to the schist. So the schist pretty much looks like a sandstone. So here we have a sandstone, and this one's a feldspathic sandstone, so it's feldspar, which makes it a bit more like just dirt that's just been put together. So if we have a quartz sandstone, you can see the difference between these two. So the quartz sandstone is a lot stronger. It's a lot harder to break. This one pretty much crumbles if you put your fingernail on it. So that's very weak in terms of its strength. And here we have a schist, and you can see the schist, it has large crystals, but it also has laminations. So that's the foliation of the rock. So it's a bit hard to see in these samples, but you can see this one looks like you can slightly see the foliation, so the lines going through it. But in this one, this looks more massive, but the foliation you can see if you see up here, so you can see the lines where these can break off. This one probably is, I would say it's derived from a sandstone. It has a lot of lighter coloured minerals, probably feldspars, quartz. It's a bit hard to tell which grains, but if you zoom in on anything, you can see that it has a lot of dark blotches. Could be garnet, I really know, but I'm saying it's most likely mica or mica, whichever one you want to say. So, and when you put this together with a sandstone, yeah, they look pretty similar. So this one under pressure can form this type of rock. So the only difference that you need to notice is that sandstone, it does have laminations. This one's massive, but the laminations can be all different thicknesses. In the schist, the foliation will be between 0.25 and 2 millimeters, so very small. But in the sandstone, the laminations can be between, you know, like 1 millimeter up to 1 millimeter, up into 1 centimeter, or even bigger. So that's a difference. And you also need to know the actual setting. Then we have our gneiss. So this one does not have any foliation, but as you can see, the separation between the micas and the granite, not the granite, the quartz and the feldspars is not complete. There's still a lot of overlap between both. You can see you got granite and feldspars. Not granite. Keep on saying that. Quartz and feldspars, and here you got a lot of micas. So that is the difference between all these rocks. So I hope this helps you with your introduction to geology. If you have any questions, please leave it down below in the comment section. But, you know, I will make a more in-depth video on these rocks. Thank you very much and have an awesome time learning geology. Thank you and goodbye.